These are the Lesson 5.2 notes on solving systems of linear equations by substitution, plus the key ideas from Lesson 5.1. Since we did not do all of the notes for 5.1, this first page will review the important information there. In 5.1, we were solving systems of equations by graphing. So I just want to start with a couple of definitions. First, a system of linear equations is a set of two or more linear equations, and they have the same variables. For our purposes, all of the ones that we will be working with just have two equations. When you get into algebra and algebra 2, you can have more equations. And the variables that we use will usually be x and y, but you could have other variables. So if you are writing a system, you have to use the same variables for all of the equations. Okay, and then the idea of what's a solution look like? A solution is an ordered pair. It's not one number, it's an ordered pair. It's an x, y. Not one number. When you find that ordered pair, then you take it and you substitute it back into both of the equations, and it should be a solution for each of the equations, not just for one. It is also, when you graph it, it's the point of intersection. So we graph one equation, we graph the other equation, and the solution is the intersection point. It has to be all three of those things in order to be a solution for the system, right? And in this chapter, we will be finding 4 different ways of solving a system of equations. Okay, so the first and easiest one is graphing when it works. So the idea for solving by graphing is that you're going to graph both of them. You'll find the point of intersection, and then you have to check it to make sure that it works. It might be leaping out at you that this is a great way to start if your answer is right on a lattice point. But it has its shortcomings in that if your answer isn't right here, if it's over here, you might not know exactly what that answer is. Sometimes graphing gives you an approximation of the answer. It gives you a ballpark, but then you need to do something else to find the exact answer. Okay, so let's graph. And another just note is that sometimes it's hard to figure out where to draw your X and Y axis. So I already have mine done so I can find that answer. But just be patient with yourself because sometimes you have to draw it again. Sometimes they end up in weird places. All right, so I'm going to draw mine here. And here. All right. And so my first equation is y equals 2x plus 5. So I'm going to go to my y-intercept, which is 5. 1, 2, 3, 4, 5. And then I'm going to graph a slope of 2. That means it's going to go up 2 over 1. But I can also go down 2, back 1, down 2, back 1. Okay. Draw that on. And this one is 2x plus 5. And then the other one is negative 4x minus 1. So we want to start at negative 1. And then this slope would go down 4 over 1, but instead I'm going to go up 4, 1, 2, 3, 4, and back 1. And up 1, 2, 3, 4, and back. Hopefully that made sense. Instead of going negative 4, positive 1, I'm going to go positive 4, negative 1. That's right. 1, 2, 3, 4, 1, 1, 2, 3, 4. Yes. And then this graph is y equals negative 4x minus 1. This point is the solution. So the intersection of the two lines is the solution. And what is that point? That point is negative 1, 1, 2, 3. Okay, so if we look back at our definition, is that an ordered pair? Yes, it is. Is it the point of intersection? Yes, it is. Let's check and make sure that it makes both of those equations true. So my solution, I think, is negative 1, 3. Let's substitute it into y equals 2x plus 5. So that would be 3 equals 2 times negative 1 plus 5. And 2 times negative 1 is negative 2. Negative 2 plus 5 is 3. So it works for that one. And then let's check it for y equals negative 4x minus 1. Substitute in 3 equals negative 4 times negative 1 minus 1. Negative 4 times negative 1 is positive 4. And 4 minus 1 is 3. All right. So you do not always have to write out the whole check, right? But you should always do the check, even if it's in your head. You grab that answer and you substitute it back in and you make sure that it works, right? Always check your answers by substituting. Okay, and so this was section 5.1. Then 5.2 goes into our second strategy, which is solving by substitution, right? To solve by substitution, you solve one of the equations for one of the variables. So you'll solve for either x or for y. Then once you have y equals something or x equals something, then you substitute that expression into the other equation and solve for the other variable. I know, lots of words. Then you take that answer and you substitute it into one of the original equations and solve, and then you'll have a solution for x and a solution for y. Okay, that's a lot of words, but in practicality, it's a little smoother. Okay, so the first thing you have to do is solve one of the equations for one of the variables. Well, both of these equations are already solved for y. So step 1 is done for us. So done. Step 2, substitute one of these expressions into the other equation, and either way works. I'm going to substitute this one, y equals 3x. If y is equal to 3x, then I'm going to substitute 3x into y equals x minus 2. And then if my y was equal to 3x, then I can substitute it in there. Right? So now I have an equation that only has one variable in it, right? Now I have written in terms of x. So I can subtract x from both sides. So now I have 2x is equal to negative 2. I'm dividing 3 by 2. X is equal to negative 1. Okay. If you had gone the other way, it would also have worked. I could have taken x minus 2 and substituted that in, actually it would come out exactly the same. It would be exactly the same. All right, then step 3, I'm going to take this x and substitute it into either one of the equations. It doesn't matter, so choose the easiest one. I think that's the easiest. So this is my x value. Okay, so now I have an answer, right? I have an answer that is, my x value is -1, and my y value is -3. And then I just need to check and make sure that I didn't make any mistakes. So my first equation was y equals 3x. So I take my y value, -3, and substitute that in. 3 times -1. Yep, -3 is equal to -3, so it works in the first equation. Let's check it in the second one. Y equals x minus 2. So now I've got -3 equals -1 minus 2. And again, -3 is equal to -3. Wow. At this point, kids are usually going, huh? Oh, and I need to make it a little bit smaller. You can't see the bottom. Hopefully I didn't cut off too much there. Okay, let's look at another one. Okay, so when I look at this one, now I can see that they are not both already solved for one variable, but the first one is. So y equals 2x minus 4 is solved for y. Look at the two equations and just pick the one that is easiest to work with. Sometimes one will already be solved for either x or y. Sometimes it's very easy to solve it. All right, so just solve for either x or y. And then you're going to, since y is equal to this, I'm going to substitute that into the other equation. So I'm going to make 7x minus 2y yes, okay, equals 5. And this is what y is. So I'm going to substitute it in right there. So now I've got 7x minus 2 times 2x minus 4 equals 5. I'm going to use my distributive property. We haven't done this in a while. You have to be sure to take the -2, take the whole thing, and distribute. So I've got -2 times 2x is -4x. And -2 times -4 is +8 equals 5. And that's another thing that you have to be really careful about when you are solving systems of equations. There's lots of places where you can make sign errors. So just check and double check your signs. Okay. So now we've got 7x minus 4x is 3x plus 8 equals 5. The 8 on the other side, so now I've got 3x. 5 minus 8 is -3. Divide 3 by 3, and x is equal to -1. Right? Now that I have an x value, I can take this and I can substitute it into either one. It doesn't matter which equation you substitute it into to solve for y. But I think I'm going to go back to the other one. So y equals 2x minus 4. So I'm going to take that x value and substitute it in. So now y equals negative 2 minus 4. Y equals negative 6. And then my step 4 is just to write the ordered pair, which is negative 1, negative 6. And then I need to check. Y equals 2x minus 4. My y is negative 6 times 2 times negative 1 minus 4. This is negative 6 equals, that's negative 2 minus 4. And then I can take my second equation, 7x minus 2y equals 5. And substitute back in 7 times negative 1 minus 2 times negative 6 equals 5. So now we have negative 7. Negative 2 times negative 6 is 12. That's always a little tricky for me. Remember me telling you that you have to change your subtraction to addition and then change the next sign? So we're going to add the opposite. And you can see where that would be helpful now, right? Because it's like, ooh, do I subtract negative 12? Oh, if I subtracted negative 12, that would be the same thing as adding 12. So it'll work either way. And that worked. So that's a correct answer, right? Lots of steps. And the more you do it, the easier it gets. Just check your signs. Right? You have 3 you tries to practice with. Right? And then we have a real life example. You buy a total of 50 turkey burgers and veggie burgers for $90. You pay $2 per turkey burger and $1.50 for a veggie burger. Write and solve a system of linear equations to find the number x of turkey burgers and the number y of veggie burgers that you buy. So the first thing we're going to define those variables. So we've got x turkey and y veggie. And so the first thing you have to do is to write the system, right? So when I look through there, I see some information. I know that I'm going to buy a total of 50 burgers. That's pretty useful. And I also have some information that is money. So I'm going to write one equation that talks about the total number of things that I bought. And I'm going to write another equation about the amount of money I spent. So if I'm going to I'm going to buy a total of 50 burgers, then I'm going to buy X number of turkey plus Y number of veggie is going to equal 50. And then my second system is that if these turkey burgers cost $2, then I've got $2 times the number of turkey burgers plus $1.50 times the number of veggie burgers equals $90 altogether. This is a pretty classic problem type and also one that you run into in real life. So recognizing that this is a number and the number of those that you bought, you multiply by the price. Maybe I'll include the word number there. And so then we can work through our equations. It makes sense to use this one, right? Because these are easier numbers to work with in this. So let's say, either way, let's solve and say y is equal to 50 minus x. So that's our step one, where we have solved one equation for one of the variables. And you could have also solved for x. We just did it this way. Okay, then we're going to take that y and substitute it. What did I do? The veggie burgers are y's, not x's. Okay, so now we need to take this value for y and substitute it into one of the equations. Let's put it here. 1.5 times, this is y, 50 minus x. So now what did I just do? Oh, equals 90. 2x plus, let's see, 1.5 times 50, that is, let's see, 150 is 50 and half of 50 is 25, so that's 75 minus 1.5x. Let's can do it in one step. If I have 2x and I subtract 1.5x, that is 0.5x. Subtract 75 from both sides is 15. And then I'm going to divide both sides by 0.5. And I think that's 30. Let's stop for a second and think about what that's telling us. So we have solved this equation and we found out that we are going to buy X turkey burgers. Then we can take this X and substitute it in, and it makes sense to go into the next one. If X is equal to 30, then Y is equal to 20. So then we have 20 veggie burgers. And then you can substitute back in to check. If I take 30 and 20, obviously that adds up to 150. Let's check 2x plus 1.5 y's equal to 90, and make sure that works. 2 times 30 plus $1.50 times 20 equal to 90. 2 30s is 60, and 1.5 20s is 30, and that does equal 90. Right? So kind of reviewing steps. First, you write the equations. Then you look at the equations and you pick the easiest one to work with and you solve it for either one of the variables. After you solve it for the variable, you think that this whole thing is equal to y. So then you take that new value for y and you substitute it in for y in either one of the equations. After you substitute it in, then you only have x's left now, right? And so you're going to solve for x. Now that you know what x is, you can substitute it back in to either one of the equations and solve for y. And then you check and make sure that your answer is correct. Right, you have one you try that's very similar. You sell lemonade for $2 per cup, orange juice for $3 per cup, a total of 100 cups that costs $240. Write and solve a system of equations to find the number of cups of lemonade and cups of orange juice that you sold. Are you impressed with yourself that you are learning how to work a problem that is that hard? That's a pretty challenging problem.